Hello friends, welcome to my new data structures and algorithm in Java tutorial series video. Friends, in this tutorial we will discuss how to remove first node from a circular singly linked list in Java. So friends, let's suppose we are given a circular singly linked list having 3 nodes, say 1, 8 and 10, whose length is 3. So friends, in our previous tutorial we discussed that we are keeping the track of the last node of the circular singly linked list through the last instance variable. So friends, below is the algorithm to remove the first node from a circular singly linked list in Java. So let's see the demonstration of this algorithm step by step. So the first thing we do is we check whether the circular singly linked list is empty or not. So if you see, circular singly linked list has 3 nodes and length is 3, therefore it's not empty. So the condition in if block comes out to be false. Moving ahead. Now in order to remove the first node from a circular singly linked list, we know that we are keeping the track of the last node, and in the circular singly linked list, last node next points to the first node. So therefore here we are creating a temp node and we are assigning the value of last dot next to it. So this temp will point to the first node because in the circular singly linked list, last next points to the first node. So it would look something like this. Moving ahead. So here we are providing an if else block, and in the if block we are checking that whether last dot next is equal to last or not. So this condition comes into picture when the circular singly linked list has only one node left. So in this case, last next points to the last because the circular singly linked list has only one element where first and the last node is the node itself. So here you can see last next is pointing to this first node and therefore it's not equal to last. So the condition in if block comes out to be false and the else part will be executed. So in the else part, the first step we do is we assign the value of temp.next to last.next. Now friends, as we want to remove this first node, we need to do two things. First we need to break this link which is being referred by last.next to the first node. So in order to remove this link, what we are doing, we are simply assigning the value of temp.next to last.next. So friends, here if you see, when we remove this first node from the circular singly linked list, the node having the data as 8 becomes the first node because this node is removed. And we also know that circular singly linked list has property that last next points to the first node. So in this step we are simply assigning the value of temp next to last.next. Now why we are doing this step is because once the first node is removed, the second node becomes the first node. So therefore last.next should point to the second node. So when this step is executed, it looks something like this. That last.next is removed and we will assign the value of temp.next to last.next. So it would look something like this. So we are breaking the link of last.next to the first node and then we are assigning it to the second node because when the first node is removed, the second node becomes our new first node. Moving ahead. And after the if else block, we simply assign the value of null to temp.next. So friends, as we are removing this first node and returning it from the method, therefore we need to break this link as well. So in order to break this link, we are simply assigning null value to temp.next. So it would look something like this. Moving ahead. And then we are decrementing the length by 1 because we know that we have removed this node from the circular singly linked list. So initially the length was 3. So now it will become 2. Moving ahead. And then we are simply returning this temp node because we have already removed it from the circular singly linked list. So it would look something like this. So friends, as soon as we have removed this link, we know that we are currently left with 2 nodes. And here you can see the node having the data as 8 becomes our new first node. And you can also see last next is pointing to this node. Therefore, if we again call this algorithm and we want to remove the first node of a circular singly linked list, the algorithm goes as follows. So again, first we check whether the circular singly linked is empty or not. So here you can see circular singly linked list has 2 nodes, therefore it's not empty. So the condition in if block comes out to be false. And the first step, we are simply creating the temp node and assigning the value of last dot next to it. So friends, here as we track the last node of the circular singly linked list and we want to remove the first node, therefore in order to reach the first node, what we do, we simply do last dot next. So this value we are assigning to a temp node and it would look something like this. So here you can see last dot next is pointing to this first node and we are assigning that value to temp. So now temp will point to the node having data as 8. Moving ahead, and then in the if block we are checking that whether last dot next is equal to last or not. So currently last dot next is pointing to this first node, therefore last dot next is not equal to last. So the condition in if block comes out to be false and the else part will be executed. So friends, in the else part what we are doing, we are simply assigning the value of temp dot next to last dot next. So in order to remove the node having data as 8, we need to first break this link which is being referred by last dot next. And we also know that when we remove this particular node from the circular singly linked list, we are left with only one node. So therefore last dot next should point to that particular node. So friends, here we are assigning the value of temp dot next to last dot next. So we know that we have to remove this link, and when we remove this particular node having data as 8, we know that now 10 will become our first and the last node both. Therefore we are simply assigning the value of temp next, which is the node having data as 10, to last next. So it would look something like this. So here you can see the link is removed and then we are assigning temp next to last next. So it would look something like this. So friends, here we have removed the link which is referring to this particular node which we want to remove. Moving ahead, and then we are simply assigning the value of null to temp dot next, because as we are returning this complete node, we need to break this link. So it would look something like this. So now temp dot next, instead of pointing to the node having data as 10, it is now pointing to null. And as we have removed this node from the circular singly linked list, we will decrement the length. So now length is 1 because we have only one node left. And in the final step, we are simply returning the temp. So it would look something like this. So friends, after the method gets executed, we are left with only one node, which is the first and the last node both, because we are keeping the track of the last node. And when the circular singly linked list has only one element left, we know that that particular node is the last node, and if we traverse to its next, then it will refer to itself because this is the first node and the last node both. And if we call this algorithm again, in order to remove this last node from the circular singly linked list, so the demonstration of the algorithm is as follow. So first we check whether the list is empty or not. So currently circular singly linked list has one node, therefore it's not empty. So the condition in if block comes out to be false. And as we want to remove the first node of the circular singly linked list, we assign the value of last dot next to temp. But here you can see we are only left with one node, therefore the last dot next is pointing to that particular node only. So after this line gets executed, it would look something like this. So here you can see temp is pointing to last dot next, which is the node itself. Moving ahead, and now we are checking whether last dot next is equal to last or not. So as we discussed earlier, this condition will come only into picture when we are left with one node. So currently here you can see last next is pointing to the last node itself. Therefore the condition in if block comes out to be true. So the if block will be executed. So friend, in this step we are assigning null to last because in order to remove this node, we have to break this link. If we break this link, then this node will be freed up. So when this statement will be executed, it would look something like this. That now last will point to null. And as we have broke this link, now this node can be removed easily. So after the if statement, the last step we do is we simply assign the value of null to temp.next. So currently here you see temp next is pointing to temp itself. Therefore we need to break this link. So here temp next is pointing to null. Moving ahead, and then we are simply decrementing the length by 1 because we have successfully removed the node. So now length becomes 0, and as here you can see last is now pointing to null. And in the final step we are simply returning the temp, so it would look something like this. So friends, after we remove all the elements, now if we again call this algorithm, so in the first step we will check whether the circular singly linked list is empty or not. So here you can see the length is 0 and last is pointing to null, therefore the circular singly linked list is empty. So the condition in if block comes out to be true, and as we know that when the circular singly linked list is empty, there are no nodes left to be removed. So therefore we can throw a no such element exception because there are no nodes left to be removed. So friends, here we saw the demonstration of the algorithm. Now let's go to Eclipse and see the working code. So friends, in my previous tutorial, we created one class by name circular singly linked list, and we implemented the code for the circular singly linked list into that particular class. So in order to understand the working of circular singly linked list, you can watch my previous tutorials. And here you can see we are keeping the track of the last node through the instance variable list node. So in this tutorial we will write the code to remove the first node from the circular singly linked list. So here let's suppose we give the method name is public list node remove first. So friends, here I have given the method name as remove first and whose return type is of list node. So this method will remove the first node from the circular singly linked list and will return it back to us. So in the first step, as we saw in the slide, we are checking that whether circular singly linked list is empty or not. So is empty. So if the circular singly linked list is empty, we will throw no such element exception. And here we provide a string as circular singly linked list is already empty. And if the circular singly linked list is not empty, then the first step we do is we create a temp list node and we'll assign the value of last dot next to it, and then we'll provide an if else block. So in the if block we provide a condition as that whether last dot next is equal to last or not. So if the last dot next is equal to last, then we'll simply assign null value to last, because we know that this condition comes into picture when there is only one node left into the circular singly linked list, and in that case if we want to remove that particular node, we need to simply assign the null value to last, because this last is referring to that particular node. And in the else part, we are simply assigning temp next value to last dot next, and after if else block we are simply assigning null value to temp next, and then we are reducing the length by 1, and in the final step we are simply returning the temp node. So friends, this is the algorithm to remove the first node from the circular singly linked list. Now let's test its working in the main method. So friends, in my previous tutorial we discussed how we can insert the node into the circular singly linked list. So we inserted 3 nodes in my previous tutorial with the data as 1, 8 and 10. And we also created one display method which could display the entire circular singly linked list. So if I run the code now, you can see it printed 1, 8 and 10 because there are 3 nodes in the circular singly linked list, 1, 8 and 10. Now let's say we are removing the first node from the circular singly linked list, and we are calling the display method again. Now if I run the code again, so here you can see initially it printed 1, 8 and 10 because we have 3 nodes in the circular singly linked list, and when we removed the first node, so 1 got removed and it printed 8 and 10. Now let's say I again call remove first method, and if I run the code now, so you can see it removed 1 and then it removed 8 and it finally printed 10. And if I call again remove first, and if I run the code, so you can see in the second line it printed nothing because it removed all the nodes from the circular singly linked list. And when we call display, so here you can see in display method we are initially keeping a condition whether last is equal to null, and if last is equal to null then we are simply returning from the method. So therefore it printed nothing because when we have removed all the nodes from the circular singly linked list, we know that last point to the null. And now if I call again remove first, and if I run the code, so you can see it gave an exception as no such element exception, and it printed message as circular singly linked list is already empty. So friends, in this tutorial we discussed how to remove the first node from the circular singly linked list in Java. So friends, usually we never return the list node from a method, and we actually return the data part of the node which we want to remove. So here if we are calling remove first, so it should remove the node but it should return us back the data part of it. So the code is similar. What we need to do is we need to change the return type to int because the data is of integer type. And here after pointing to the first node by going through last.next, we create an integer variable which stores the data of the first node. So we simply assign temp.data to result integer variable. So initially we were making temp.next point to null. We were doing this step because we are only returning back the list node. So now when we are returning back the data part of it, we don't require this step because this node will be automatically garbage collected by Java. And in the last step, we are simply returning back the result. So friends, initially we removed the first node from the circular singly linked list and we returned it back. And after some modification, we are returning back the integer value. So let's test the working of this method. So here we'll just print the data which this remove first will return us back. So here we will call remove first. So here you can see there are 3 nodes, 1, 8 and 10, and then we are removing the first node. So therefore it should print the value as 1 because 1 is the first node of the circular singly linked list. And if I run the code, so here you can see initially it printed the 3 nodes with data as 1, 8 and 10, and then it removed the first node which is 1 and it printed it on the console. And when we did display again, there were 2 nodes left which is 8 and 10. So friends, in this tutorial we discussed how to remove the first node from the circular singly linked list in Java. I hope you like this video. Please like, comment, share and subscribe my YouTube channel. Thanks, have a nice day.